Okay, so for solving equations, these are a version of Carnell notes. So we have our topic, which is the solving equations. You can put your date in your notes. And then the left side is our main ideas that we had, and then we can add some extra notes to that. And then at the bottom, we'll have some examples for you guys to practice with that I will put the answer keys up, but I probably won't walk through all of them with it because we'll do an additional example in with our notes. All right, so our main ideas, we have, this is our goal, is to get the variable alone. These are special cases. And special cases happen when your variable cancels out, so you end up with no variables. If you end up with something that's not true, like 5 equals 8, then you would have no solution. And if all of your variables cancel out and you end up with something that's true, like x equals x or 0 equals 0, then your answer is all real numbers are solutions. All right, so where you are in math is you've got a lot of skills and a lot of abilities of how to do stuff, and you've been shown how to do things specific ways, but now you get to mix and match and add things together. So it's not going to be always just only one right way to do things. There's going to be a, is your answers making sense? Are you looking for a way that works for you using the tools that you already have? So when we're solving equations, we have done some traditional things, which is we could say our steps are simplify each side. And when you're simplifying each side, you're using the order of operations. And then once you've simplified each side, then move variables to one side, numbers to other, by doing the opposites. Okay, so that's our first step. That would be our second step. And then you'll get the variable all by itself and you'd be done with the problem. Now, there is an alternate way to do it. So you have choices, like I said. You can do things the way that you've always seen it, and it's a great way of doing it. It will always work. But sometimes you end up with stuff that's not so pretty when you're doing it. So another way that we could do this, I'm going to put it as option 2, is we can move things away from the variable. By doing the opposites. So away from the variable, other side. By doing opposite operations. And when we're doing those opposite operations, what we're going to do is kind of the opposite of order of operations. So we're going to move anything that's added or subtracted first. Then we get rid of anything multiplied or divided. And then we get rid of parentheses and that kind of stuff. So if we do the second option, we're kind of going to do things in reverse of how we've done order of operations, but we're really thinking of how we can move things from one side to the other. So this is going to be, we're going to look at it with our example. So I do have another example for us that's going to probably cause a little bit of stress for people. It is going to be the problem 1/3 times 5x plus 2 minus 8 equals 4 times x minus 6 plus 5. Now, whenever I solve equations, sometimes I will put a line through the equal sign just so I can keep my two sides separate. And then I look at the whole thing that I'm dealing with. So in this problem, on the left-hand side, I have that 1/3. If I distribute that 1/3 to everything in the parentheses, um, I'm going to have fractions because 1/3 times 5 is 5/3. I'm going to be left with that fraction. And 1/3 times 2 is 2/3. 3 doesn't go into either 5 or 2. That's just going to add to ugliness on that side. So I'm going to wait on the left side. If I simplified the 4 times x minus 6, that's nice numbers. So that distributing makes sense. So that's probably going to be the first thing I'm going to do. I'm going to ignore the left side and work on the right side. So distribute the 4. So I have 4x. And 4 times negative 6 is minus 24. And then I still have this plus 5 hanging out. Simplifying this a little bit more, I'm going to combine my like terms. So I have 4x minus 19 on this side. Works good, not too bad. And I have to now deal with that left-hand side. Not looking so fine. So what I'm thinking about with this is I've simplified the right side as much as possible, which is kind of looking at solving my equation like that first method. But then I'm looking at the second part and I'm thinking, oh, that's not so good. So what I'm really thinking is mixing and matching the two possibilities that I have. So now I'm going to think, all right, if I had that left side, how would I get rid of everything from away from that x? So if I'm looking at that, the first thing I'm going to do, so I'm mixing and matching both of my ways. So I'm going to add 8 to move it over to by doing the opposite. So I'm going to add 8 over here. So this still gives me that 1/3 and the 5x plus 2. Those 8s will cancel out, and that's going to now equal 4x minus 11. All right, so thinking about how things are attached, that 1/3 is times those parentheses. Distributing it, we determined, gave us ugly fractions. So this case, I want to get rid of that 1/3, and I'm going to do the opposite. So I'm going to divide by 1/3, and I can divide by 1/3, and I don't have to write the division that way. I could change it to say that this is the same thing as 4x minus 11 divided by, because that's what a fraction, that divided by means, 1/3. And then I can think back of my rules for dividing by fractions, and I always do a keep, a change, and a flip. So this is the same thing as 4x minus 11 times, because change from division to multiplication, and flip this. This is 3 over 1, which means I have the problem, this 1/3 cancels with this 1/3. So I have 5x plus 2. Don't need those parentheses anymore. And it's going to equal 4x minus 11 times 3. So now I can go back and say, ooh, I can simplify each side as much as possible now that I've moved things away from that parentheses. So distributing, I'm going to have 12x minus 33 equals 5x plus 2. Now it's an equation like we've seen before in other classes, and I'm going to get the x's on one side, the numbers on the other side, and I'm going to start by moving the smaller x. So I'm going to go minus 5x. This is where we're doing the opposites, minus 5x. And these will cancel out, so I have 7x. And now, before I finish rewriting this stuff, I'm going to think, okay, the 7x is now on the right-hand side. I want to get rid of anything else that's added or subtracted, any of the plain numbers. So it's technically a separate step, but I'm going to write it in the same thing. So I'm going to move that 33 to the other side by plus 33. Those will cancel out, and then I'll have 7x equals 35. Assuming I did things right. Awesome. And then I'm going to divide both sides by 7, divide both things by 7, and I get x equals 5. So my numbers actually worked out pretty nice. Even though I had that fraction in there and I would have had to deal with a lot of fractions. It's not a guaranteed. I could have ended up with a fraction with this as well. So that's just mixing and matching with the steps, with the rules, and what we have. All right, so what I would like you guys to do is take a little bit of time, practice with these type of problems, see what we have. I will put the answers with the work up with my solutions, and hopefully it'll be good and we can answer some more questions, because I really don't want to make a long video for you guys. All right.